Across the surface of this planet, humanity has always dreamed beyond the present, imagining structures that defy logic and rewrite the limits of engineering. These are not ancient wonders, but visions of tomorrow, megaprojects so vast they seem impossible, yet they are already being built. From cities rising in the desert to bridges spanning entire seas, each one represents a new chapter in our species' refusal to accept boundaries. The future is being constructed right now.
So if you want more journeys into the unforgiving, the beautiful, and the unknown, subscribe. Hit that button and join us as we explore the places that don't fit on postcards.
And its scale will leave you breathless. If you're ready to witness what comes next, subscribe now and join us on this journey into the world of tomorrow. Let's begin. NEOM stands in the barren desert of northwest Saudi Arabia, covering more than 10,000 square miles where sand, rock, and absolute silence have ruled for millennia. The entire region will be powered by renewable energy alone with zero carbon emissions, making it the first megacity designed to exist without fossil fuels. At its heart lies the Line, a linear city stretching over 100 miles long but only 650 feet wide, where 9 million people will live in a mirrored structure rising 1,600 feet above the desert floor. No cars will exist inside, no roads will be built, and every resident will reach any point within the city in less than 20 minutes using high-speed rail hidden beneath the ground. The outer walls are covered entirely in mirrors, reflecting the desert and sky, making the structure nearly invisible from a distance. Engineers estimate that excavation alone will move more than 1 billion cubic meters of earth and rock, equivalent to digging the Suez Canal twice. Inside, artificial intelligence will manage energy, water, transportation, and even air quality, learning from millions of sensors embedded in every surface. The city will grow its own food in vertical farms, using 95% less water than traditional agriculture, fed by desalination plants pulling moisture directly from the Red Sea. Construction costs are projected to exceed $500 billion, making it the most expensive urban project ever conceived by a single nation. When you imagine walking inside, you see no horizon, only two endless mirrored walls rising toward the sky, with the sun cutting a narrow line of light overhead. NEOM is not just a city. It is humanity's attempt to prove that technology can reshape existence itself. The Hong Kong-Macau Bridge is the longest sea crossing ever built, stretching more than 34 miles across the Pearl River Delta, where salt water, heavy shipping traffic, and tropical storms converge. It took 9 years to complete, using over 400,000 tons of steel, enough to build 60 Eiffel Towers, and required the pouring of concrete equivalent to filling 140 Olympic swimming pools. The bridge included a 4-mile underwater tunnel built inside the seabed to allow large cargo ships to pass without interruption, connected by 2 artificial islands constructed from more than 1 million tons of rock and sand. Engineers designed it to withstand earthquakes up to magnitude 8, typhoons with winds exceeding 200 miles per hour, and direct ship collision from vessels weighing up to 300,000 tons. The tunnel sections were prefabricated on land, each weighing 80,000 tons, then floated into position and lowered into a trench dug 150 feet below the ocean surface. To protect the local Chinese white dolphin population, construction was paused during breeding seasons, and underwater noise was monitored continuously to prevent ecological disruption. Drivers crossing the bridge experienced a surreal shift, moving from open sky to complete submersion beneath the sea, then emerging again into daylight on the other side. The bridge reduces travel time between Hong Kong and Macau from 3 hours by ferry to just 30 minutes by car, linking 3 major cities into a single economic zone. Standing on one of the artificial islands, you feel the wind pull at your skin, hear the hum of traffic above, and the silent weight of the ocean below. This is not just infrastructure. It is proof that humanity can command the sea itself. Jeddah Tower rises in the desert of Saudi Arabia, designed to reach over 3,280 feet into the sky, making it the tallest building ever attempted by human hands. Its height surpasses the Burj Khalifa by more than 560 feet, pushing engineering into territory where wind, gravity, and material stress demand entirely new solutions. The foundation required the excavation of sand down to bedrock, over 200 feet deep, then the pouring of a reinforced concrete base weighing more than 80,000 tons. The structure uses a 3-pedal design that tapers as it rises, reducing wind resistance and allowing the tower to sway up to 6 feet at the top during extreme storms. Over 5.7 million square feet of floor space will house luxury apartments, offices, observation decks, and a Four Seasons hotel suspended nearly half a mile above the ground. Engineers estimate that during peak construction, more than 10,000 workers will operate around the clock, lifting materials using cranes designed specifically for extreme altitude. The outer skin is clad in glass and metal panels engineered to reflect desert heat, while allowing natural light to fill the interior, reducing energy consumption by nearly 30%. At the top, an observation deck will offer views extending more than 50 miles in every direction, where the curvature of the Earth becomes visible to the naked eye. Elevators will travel at speeds exceeding 33 feet per second, covering the full height in less than 2 minutes, creating a sensation of weightlessness as the cabin accelerates. The project has faced delays, funding challenges, and geological surveys that required years of analysis, yet construction continues with the goal of completion before the end of this decade. When you stand at its base and look up, the tower seems to pierce the atmosphere, a vertical line drawn between Earth and space. Jeddah Tower is not just tall, it is humanity's declaration that height has no ceiling. The International Thermonuclear Experimental Reactor, known as ITER, is being built in southern France to replicate the nuclear fusion process that powers the sun, attempting to create unlimited clean energy on Earth. The reactor chamber, called a tokamak, weighs over 23,000 tons and uses the strongest magnetic fields ever produced by human technology to contain plasma heated to 150 million degrees Celsius, 10 times hotter than the core of the sun. 35 nations are collaborating on the project, pooling resources, knowledge, and over $20 billion in funding to prove that fusion energy is not science fiction but achievable reality. The magnetic coils are made from niobium tin superconductors cooled to minus 270 degrees Celsius, colder than outer space, creating a temperature difference of over 420 million degrees within a structure smaller than a tennis court. If successful, ITER will produce 500 megawatts of fusion power from just 50 megawatts of input energy, achieving a tenfold energy gain never before demonstrated in a controlled environment. Construction required the fabrication of components so precise that tolerances are measured in fractions of a millimeter, despite parts weighing hundreds of tons and being manufactured on different continents. The vacuum vessel alone is 9 stories tall, built from steel sections welded together with such accuracy that leaks are impossible even under extreme thermal and magnetic stress. Inside, deuterium and tritium, isotopes of hydrogen extracted from seawater and lithium, will fuse together, releasing energy without producing long-lived radioactive waste or greenhouse gases. The first plasma is expected before 2030, marking the beginning of tests that could reshape global energy production for centuries. Standing in the assembly hall, you see components larger than houses being moved by cranes with millimeter precision. Each be a fragment of humanity's most ambitious scientific experiment. ITER is not just a reactor. It is proof that we are ready to harness the power of stars. The East Side Coastal Resilience Project in New York City is being designed to protect Lower Manhattan from rising sea levels and storm surges caused by climate change, using a combination of flood walls, parks, and deployable barriers stretching more than 2 miles along the waterfront. After Hurricane Sandy in 2012 caused over $19 billion in damage and flooded subway tunnels with millions of gallons of seawater, engineers recognized that traditional infrastructure was no longer sufficient. The project includes raising the land by up to 8 feet in certain areas, creating elevated parks that double as flood barriers while providing green space for residents. Flip-up flood walls made from steel and reinforced concrete will remain hidden below ground until sensors detect rising water, then deploy automatically within minutes to form a continuous barrier. The design integrates with the city's historic architecture, ensuring that protection does not erase the character of neighborhoods that have existed for over 2 centuries. Engineers estimate that construction will require moving more than 500,000 cubic yards of soil, installing thousands of tons of steel, and rebuilding sections of the FDR Drive, one of the city's main traffic arteries. The project also includes new drainage systems, pump stations, and green infrastructure designed to absorb rainwater and reduce flooding from heavy storms. When complete, it will protect over 100,000 residents and critical infrastructure, including hospitals, power stations, and transportation hubs that serve millions daily. The total cost is projected to exceed $1.45 billion, funded by a combination of federal disaster relief, city budgets, and climate adaptation grants. Walking along the waterfront, you will see parks where children play, unaware that beneath their feet lies a system designed to hold back the ocean itself. This is not just a fence. It is humanity learning to coexist with a planet in transition. The Beijing Daxing International Airport is one of the largest and most advanced aviation hubs ever constructed, covering over 18 square miles with a terminal building shaped like a starfish that allows passengers to walk from security to any gate in less than 8 minutes. Designed by the late architect Zaha Hadid, the structure uses a flowing organic form with a roof supported by just 8 columns, creating vast open spaces filled with natural light from skylights that eliminate the need for artificial lighting during the day. The terminal has over 4 million square feet of floor space, making it one of the largest single buildings on Earth, yet it maintains energy efficiency through advanced climate control and automated systems. Construction required the pouring of over 1.6 million cubic meters of concrete, the installation of 52,000 tons of steel, and the coordination of more than 50,000 workers at peak activity. The airport is designed to handle 100 million passengers annually, with plans to expand capacity to 200 million, making it potentially the busiest airport in the world. Below ground, high-speed rail lines connect directly to the terminal, allowing travelers to reach central Beijing in less than 20 minutes and reducing car traffic by millions of trips per year. Engineers incorporated over 8,000 skylights and windows into the design, reducing energy consumption for lighting by more than 30% compared to traditional airports. The airfield includes 4 runways with advanced navigation systems that allow simultaneous landings even in low visibility. increasing efficiency and safety. When you walk to the terminal, you feel the space breathe around you. Curves instead of corners, light instead of shadows, flow instead of congestion. Beijing Daxing is not just an airport. It is a vision of how infrastructure can blend beauty, efficiency, and scale into a single experience. The Great Green Wall of Africa is a continent-spanning ecological restoration project stretching over 4,800 miles from Senegal on the Atlantic coast to Djibouti on the Red Sea, aiming to plant a living barrier of trees and vegetation to stop the expansion of the Sahara Desert. Launched in 2007, the initiative involves 21 countries working together to restore 250 million acres of degraded land, creating jobs, capturing carbon, and reviving ecosystems that have been disappearing for decades. So far, over 37 million acres have been restored, with millions of trees planted including acacia, baobab, and drought-resistant species adapted to survive in harsh, arid climates. The project is not just about planting trees. It includes water harvesting, soil restoration, sustainable agriculture, and the creation of green jobs for rural communities facing poverty and migration. In Senegal, over 27 million trees have been planted, transforming barren land into productive forests that provide food, firewood, and income for thousands of families. In Ethiopia, over 37 million acres of degraded land have been restored, improving food security and reducing the impact of droughts that once displaced entire populations. Scientists estimate that when complete, the Great Green Wall will sequester over 250 million tons of carbon, helping to slow climate change while providing livelihoods for millions of people. The project has attracted funding from international organizations, governments, and private donors, with over $14 billion pledged to support its completion by 2030. Challenges remain: droughts, political instability, and limited resources slow progress in some regions. Yet the vision continues to grow as communities see the tangible benefits of restored land. Walking through a newly planted section, you see young trees rising from dry earth, their roots reaching deep, their leaves catching the wind. The Great Green Wall is not just a mega project. It is humanity planting hope across an entire continent. The Gotthard-based tunnel in Switzerland is the longest and deepest railway tunnel in the world, stretching 35.5 miles beneath the Alps and reaching depths of over 8,000 feet below the surface. Construction took 17 years, required the excavation of 28 million tons of rock, and cost over $12 billion, making it one of the most complex engineering projects ever completed. The tunnel allows trains to travel at speeds up to 155 miles per hour, cutting travel time between Zurich and Milan by over an hour and reducing the need for trucks to cross the mountains by road. Engineers use 4 massive tunnel boring machines, each over 1,300 feet long and weighing 3,000 tons, to drill through solid granite and ice and sedimentary rock under extreme pressure and temperature. Inside the tunnel, temperatures reached up to 115 degrees Fahrenheit due to geothermal heat, forcing workers to operate in specially cooled sections and take frequent breaks. The tunnel is designed to last over 100 years, with reinforced concrete, linings, advanced ventilation systems, and emergency stations every 1,000 feet for passenger safety. Over 2,400 workers from multiple countries participated in construction, working in shift around the clock. facing risks from rockfalls, flooding, and equipment failure. When the two tunnel sections met in the middle, the alignment error was less than 2 inches over a distance of more than 35 miles, a testament to precision surveying and GPS technology. The project reduced carbon emissions by shifting freight transport from road to rail, removing over 1 million truck trips per year from alpine highways. Traveling through the tunnel, you experience complete darkness, the hum of the train, and the knowledge that millions of tons of mountain rest just feet above your head. The Gotthard Base Tunnel is not just infrastructure. It is proof that mountains are no longer obstacles. The Qinghai-Tibet Railway is the highest railway in the world, crossing the Tibetan Plateau at altitudes exceeding 16,000 feet, where oxygen levels drop to half of what exists at sea level. The track stretches over 1,200 miles from Xining to Lhasa, passing through permafrost, frozen tundra, and mountain ranges where temperatures can fall below minus 40 degrees Fahrenheit. Engineers built the railway on elevated bridges and embankments filled with cooling tubes to prevent the permafrost beneath from melting and destabilizing the track. Passenger trains are equipped with pressurized cabins and oxygen supply systems to prevent altitude sickness, making it feel like traveling inside an aircraft while moving across land. Construction required over 100,000 workers, many operating under extreme conditions with limited oxygen, where physical labor becomes exhausting within minutes. The railway includes a Tangula Pass, the highest point on any railway in the world at 16,640 feet, where passengers can see snow-covered peaks stretching endlessly in every direction. Wildlife tunnels and migration corridors were built alongside the track to protect Tibetan antelope, wild yaks, and other species native to the plateau. The project cost over $4.2 billion and took 5 years to complete, overcoming engineering challenges that many considered impossible. Riding the train, you watch the landscape shift from green valleys to barren rock, then to white expanses where earth and sky merge into one. The Qinghai-Tibet Railway is not just a train line. It is humanity reaching the roof of the world. The Palm Jumeirah in Dubai is an artificial island shaped like a palm tree, built entirely from sand and rock dredged from the bottom of the Persian Gulf and arranged into a design visible from space. Construction required the placement of over 100 million cubic meters of sand and 7 million tons of rock, moved by a fleet of dredging ships working continuously for years. The island adds over 35 miles of new coastline to Dubai, providing beachfront property for luxury villas, hotels, and resorts in a city where coastal land is limited. The outer crescent acts as a breakwater, protecting the inner fronds from waves and erosion, built from rocks weighing up to 6 tons each and stacked with precision to withstand storms. Engineers use GPS technology to position each grain of sand within centimeters of the planned design, ensuring the palm's shape remained accurate despite tides, currents, and wind. The project faced environmental concerns as dredging altered seabed ecosystems and disrupted marine life, leading to stricter regulations for future developments. Over 10,000 workers participated in construction, operating cranes, ships, and machinery in temperatures exceeding 120 degrees Fahrenheit during summer months. When complete, the Palm Jumeirah became home to over 25,000 residents and attracts millions of tourists annually, making it one of the most recognizable megastructures on Earth. From the air, you see the perfect symmetry of the fronds, the crescent embracing the trunk, and the glittering towers rising from sand that was once ocean floor. The Palm Jumeirah is not just an island. It is proof that geography can be rewritten. The Channel Tunnel, known as the Channel, connects England and France beneath the English Channel through 3 parallel tunnels stretching over 31 miles, with 23 miles lying underwater at depths up to 250 feet below the seabed. Construction began simultaneously from both sides in 1988, using 11 tunnel boring machines to drill through chalk marl, a soft sedimentary rock that allowed faster progress but required constant reinforcement. Engineers faced unexpected challenges, including water ingress, equipment breakdowns, and discovered geological faults that forced route adjustments mid-construction. Over 13,000 workers participated, excavating more than 9 million cubic meters of material, enough to fill 3,600 Olympic swimming pools. The tunnel allows trains to travel at speeds up to 100 miles per hour, completing the journey from London to Paris in just over 2 hours, revolutionizing travel between the UK and continental Europe. Ventilation systems circulate air through the tunnels, while cooling systems prevent temperatures from rising due to friction and geothermal heat. Safety features include cross passages every 1,250 feet. allowing passengers to evacuate into a parallel tunnel in case of emergency, and fireproof doors designed to contain smoke and flames. The project cost over £9 billion, faced political opposition, financial crises, and engineering setbacks, yet was completed in 1994, marking one of the greatest achievements of 20th century infrastructure. Riding through the tunnel, you experience a brief moment of stillness, no view, no sound except the hum of the train, and the awareness that you are traveling beneath the sea. The Channel Tunnel is not just a passage. It is the physical bond between two nations. The Three Gorges Dam in China is the largest hydroelectric power station in the world, standing over 600 feet tall and stretching more than 1.4 miles across the Yangtze River. The dam's reservoir extends over 400 miles upstream, holding more than 39 trillion liters of water, enough to alter the Earth's rotation by a measurable fraction of a millisecond. Construction required the relocation of over 1.3 million people, the flooding of ancient towns, temples, and archaeological sites, making it one of the most controversial megaprojects ever built. The dam generates over 100 terawatt-hours of electricity annually, supplying power to hundreds of millions of people and reducing China's reliance on coal by an estimated 50 million tons per year. Engineers poured over 28 million cubic meters of concrete and used 463,000 tons of steel, creating a structure designed to withstand earthquakes, floods, and the immense pressure of the reservoir behind it. The dam includes ship locks that lift vessels over 370 feet, allowing cargo ships weighing thousands of tons to navigate between different water levels. Environmental impacts include altered river ecosystems, increased sedimentation, and concerns about the dam's effect on endangered species, such as the Yangtze sturgeon. The project took 17 years to complete, cost over $30 billion, and transformed the region's economy, flood control, and energy infrastructure. Critics argue that the social and environmental costs outweigh the benefits, while supporters point to the dam's role in preventing catastrophic floods that historically killed thousands. Standing at the dam's edge, you hear the roar of water passing through turbines, feel the vibration in the ground, and see the river transformed into a controlled force. The Three Gorges Dam is not just engineering. It is humanity reshaping nature on a planetary scale. Masdar City in the United Arab Emirates is being built as the world's first carbon-neutral, zero-waste city, designed to house 50,000 residents and 1,500 businesses, while producing zero emissions. Located in the desert outside Abu Dhabi, the city uses solar panels, wind towers, and advanced insulation to generate all its energy from renewable sources, eliminating dependence on fossil fuels. Streets are narrow and shaded to reduce heat, while buildings are designed using traditional Arabic architecture that maximizes airflow and minimizes the need for air conditioning. The city's transportation system relies on electric, driverless pod cars that run beneath street level, eliminating traffic, pollution, and the need for parking spaces. Construction began in 2008 with completion planned for the 2030s. Though progress has been slower than initially projected due to funding challenges and the complexity of integrating sustainable technologies. The city includes research centers, universities, and innovation hubs focused on clean energy, attracting scientists and companies working on solar power, carbon capture, and sustainable urban design. Water is provided through desalination powered entirely by renewable energy, with wastewater treated and recycled for irrigation and cooling systems. Waste is sorted, composted, or converted into energy, with the goal of sending zero material to landfills. Walking through Masdar City, you feel cooler air despite the desert heat, hear the quiet hum of electric vehicles, and see architecture that blends technology with tradition. Masdar City is not just urban planning. It is a living experiment in whether humanity can build a future without destroying the planet. The Delhi-Mumbai Industrial Corridor is a massive infrastructure project spanning over 900 miles across India, designed to create a high-tech industrial zone connecting two of the country's largest cities. The corridor includes new airports, seaports, power plants, water treatment facilities, and 24 new smart cities built from scratch with modern infrastructure and sustainable design. The project aims to generate 100 million jobs, increase manufacturing output, and transform India into a global industrial hub capable of competing with China and other emerging economies. Investment is projected to exceed $100 billion, funded by a combination of government budgets, international loans, and private sector partnerships. The corridor will include dedicated freight railways, highways, and logistics hubs designed to reduce transportation costs. and improve efficiency for manufacturers. New cities within the corridor are being designed with smart grids, renewable energy, water recycling, and digital infrastructure to support future industries, including robotics, artificial intelligence, and biotechnology. Construction is being coordinated across multiple states, requiring cooperation between regional governments, federal agencies, and international consultants. Challenges include land acquisition, environmental approvals, and the displacement of rural communities whose land is being converted for industrial use. When complete, the corridor is expected to contribute over 10% of India's GDP, reshaping the nation's economy and positioning it as a leader in global manufacturing. Traveling along the corridor, you see construction sites stretching for miles, cranes lifting steel into the sky, and roads being paved through fields that were farmland just years ago. The Delhi-Mumbai Industrial Corridor is not just development. It is India building its future at a scale never before attempted. The South-to-North Water Diversion Project in China is the largest water transfer system ever built, designed to move over 44 billion cubic meters of water annually from the Yangtze River in the south to the arid northern regions, including Beijing. The project includes 3 main routes, eastern, central, and western, stretching thousands of miles through tunnels, canals, aqueducts, and reservoirs. The eastern route uses a series of pumping stations to lift water over 200 feet uphill, requiring massive amounts of energy to move billions of liters against gravity. The central route includes a canal over 800 miles long, cutting through mountains, farmland, and urban areas, with sections elevated on concrete aqueducts to cross valleys and rivers. Construction began in 2002 and continues today, with costs exceeding $80 billion, making it one of the most expensive infrastructure projects in history. Over 300,000 people were relocated to make way for reservoirs and canals, facing displacement, compensation disputes, and the loss of ancestral land. The project aims to address severe water shortages in northern China, where over 400 million people face limited access to clean water due to over-extraction, pollution, and climate change. Environmental concerns include the disruption of river ecosystems, the spread of pollutants, and the impact on the Yangtze River's flow and biodiversity. Engineers face ongoing challenges maintaining water quality, preventing leaks, and managing the vast infrastructure network. that spans climate zones from tropical to arid. When water from the south reaches Beijing, it travels through treatment plants, pipelines, and distribution systems, eventually flowing from taps and homes where scarcity was once a daily reality. The South to North Water Diversion Project is not just plumbing, it is humanity rewriting the hydrology of an entire nation. The James Webb Space Telescope is humanity's most powerful observatory, positioned 1 million miles from Earth at a point where gravitational forces allow it to remain stable while observing the deepest reaches of the universe. The telescope's primary mirror measures 21 feet across, composed of 18 hexagonal segments coated in gold, each aligned with nanometer precision to function as a single reflective surface. Unlike previous space telescopes, Webb operates in infrared wavelengths, allowing it to see through cosmic dust and observe light from the first galaxies formed over 13 billion years ago. The sun shield, as large as a tennis court, protects the instruments from solar radiation, keeping them cool to minus 370 degrees Fahrenheit, colder than the surface of Pluto. Construction took over 20 years, involved thousands of scientists and engineers from 14 countries, and cost approximately $10 billion, making it one of the most complex scientific instruments ever built. The telescope was launched in December 2021 aboard an Ariane 5 rocket, then traveled for a month to reach its final orbit, deploying its mirror and sun shield in a sequence requiring hundreds of precise mechanical steps. Since becoming operational, Webb has captured images of star formation, exoplanet atmospheres, and galaxies so distant their light has traveled across most of the universe's history to reach us. Data from the telescope is reshaping our understanding of cosmology, planetary science, and the conditions that allow life to exist. Observing Webb's images, you see structures of gas and dust glowing in infrared, stars being born, and the universe as it existed when time itself was young. The James Webb Space Telescope is not just technology. It is humanity's eye on the origin of everything. The future is not a distant idea. It is being built right now, in deserts, beneath oceans, across mountains, and beyond our planet. These megaprojects are proof that human imagination, when combined with technology, resources, and determination, can reshape reality itself. Subscribe now to stay connected with the structures, innovations, and visions that will define tomorrow, and never miss a journey into the impossible made real.